Hey, we're going to finish up on SQL today. Um, so last time we were writing queries in either the SQLite command line, or you might be using the GUI, the DB browser, the SQLite DB browser. And we're going to continue writing queries today, just for a little bit. We'll finish off F, and then we're going to move to aggregation queries. All right, the group by stuff, which is also very useful. And that's all we're going to do for SQL. And I think probably that's all we have time for anyway. But we're going to throw in one more curveball today, and that is you're going to be using SQL from Python. All right. So I've put some code into the notebook already. So if you, like I said, for those who step in late, download this Python notebook file, and then go ahead and sort of fire up your Jupyter notebook. Should look like this. You guys have already installed SQLite. Now you need the SQLite 3 Python module, and we're going to be using the same database from the last class. So make sure that it'll be easier if you put that same prod.db file in the same directory as the Python notebook. Or the other way, you can put your Python notebook file in the same directory and just fire off your notebook from that directory, just to make life easier. Otherwise, you have to figure out how to specify the full path to the database file. It's not the end of the world, it just complicates life a little bit. Right? This is a link to the SQLite 3 API docs, and you can take a look at that. But in general, right, in fact, almost all SQL APIs will have some versions of these steps. What you need to do is you need to connect to the database. And even though SQLite runs embedded, you don't really need that step, but just for compatibility with other databases, we still have that step. But in this case, so I'm going to import SQLite 3. I'm importing this package called pprint for pretty print. It's just convenience for printing arrays and making it look nice. All right, just synthetic sugar for the eyes. All right, so typically, first thing you do is you have to connect to the database, and in this case, it is the database reside in a file. If you are connecting to, say, a Postgres SQL, you will need to use a different Python API for Postgres. If you're using Oracle, there will be a Python module for accessing Postgres or MySQL. So you have to use the appropriate module for that. All right. But again, in those modules, there's going to be a connect command which you're going to connect, and for those databases, because they run on a server, you need to specify a IP address or a URL. And if the database server is running on the same machine, it can be just localhost. You have to specify the port number, which usually is a well-known port. Each vendor has its own default port number. And you need to specify the username and password, and sometimes the database name, depending on which vendor. You're going to need all these pieces of information in your connect command. Like this SQLite is very simple, so it's just a file name. All right. After you connect, the connect command will return you a connection, and as the name implies, think of this as literally like a connection, like it's like a phone call. All right, so you're calling your database, and as long as the connection is up, your queries are going to work. If the connection is broken somehow, or you closed it, then it's like you put down the phone, you can't talk to the person anymore. All right. So from the connection object, CONN, right, you're going to create what's called a cursor. A cursor is like an iterator, or it's like a way to iterate through a list of tuples or table, row by row. All right. And then with the cursor, you're going to call an execute command, and you can execute a SQL query as a string. So you put your SQL query as a string, okay, and put that as the first argument of the execute command. Right? It's going to execute that that query, but you need to use a fetch command to bring the data back into Python. All right. There are different versions. I'm using fetch all. Sometimes you use fetch one if you just want a single tuple, for example, right? You can take a look at the API docs for that, right? But it's good enough for us to do fetch all, and it's going to fetch all. It's going to basically fetch everything into an array, all the rows into an array, all right? And then, so I put it into an array called data or results, and I'm just using pretty print to just print the data.
So what you're saying there is that in order to use SQL in Jupyter, you have to use the curs.execute, put all of your SQL stuff into that parenthetical statement, and then the data equals PP. Okay.
Yeah. Okay. Then you can fetch the result of the query into an array, into a Python array. Okay. There is a slightly different way of doing it, which is using parameters. It means that I can parameterize my queries. I mean, you can kind of do it using string operations as well by constructing a SQL string using concatenation and whatnot. So you put in, because sometimes you want to input variables that are within your Python environment, and you want to use the contents of those variables in your SQL statement. All right. For example, I mean, I have an example here where I have a parameter. So params is a tuple or a list, but the difference between the round brackets and square brackets is that if you put things in round brackets, that list is officially a tuple, which is not updatable. It's a read-only list. All right. And in order to force it to be interpreted as a list, you need a comma at the back, because this is just a single element. If it's a single element, you need a comma at the back to force it to interpret that as a list, a tuple. Okay. And then you're going to have these unknown parameters represented by question marks in your SQL. Okay. And these question marks will be filled out using the values in the params array or the params tuple. Okay, so you supply params as a second argument into execute, right? And you do a fetch all. Okay, so this one is a query from our example. They do. Right. Okay, did something bad. The first query is, I'm just showing you a query to query the database catalog tables. The database stores the schemas of your tables in its own catalog tables, which you can query. And this is the result that you're going to see. So I'm going to go ahead and execute that. And so the results of the first query are here, right? And the results of the next query are here. All right. So go ahead and try and execute that to see if your SQLite Python module is set up correctly. Right? Hopefully it is. Again, try and put prod.db. I mean, if you didn't name it prod.db, it can be any other name. Okay, just It's the name of the database file that you created last class with SQLite command line or DB browser. Alright. So I'll give you a couple of minutes for that, and let me know if you guys have any issues. All good? Really? This is unusual. What's the chances of that? Okay, good. That means we can move on. So let's go ahead and finish up on those queries. Find the model numbers of all color laser printers. This is relatively easy. Oh, you see above that I use the order by clause, so that's a good example of an order by clause. Where what's the printer thing? It was color. Color equals to true. And type equals to laser. Oops. So did I have the semicolon? Oh. Yeah. So I think I can use double quotes so I can escape it.
You can just use double quotes on the outside.
That's a good idea then. Yeah. Sometimes this is sometimes the environment is too smart, and it tries to complete stuff for you. And it's wait, no, there
Like
is.
that, give me a double quote.
Ah, yeah. Okay. Good. All right, and then do the same thing. You know, within a string, you could, if you want to make it stretch multi-line, you could escape it with a backslash. If you want to sort of make it a bit more readable, that's fine. Sometimes it's not necessary. Type is equals to on top except select record from product where type is equals to PC. Oops. Right? I think most of you got that, right? That's something you're supposed to have done at home. Make it all look nice by doing this. Okay, so start thinking about this one, F. I think F is going to be a little bit more challenging. Just going to cut and paste. See that?
So issue, I think I'm probably gonna ask the same thing. So how come yours is returning A, B, E, F, G?
Yeah, I was gonna say the same thing.
Because
Is that
F and G is the right answer.
And except's not working in MySQL, it's telling me it's in the wrong place. So,
Try putting a parenthesis on the block, like putting a parenthesis here,
from the beginning of select,
yeah, to here, and see whether that helps it. I'm not sure if how sensitive they are to this. Okay, but we say we have wrong answers. Okay, what's going on? Does yours return the right answer?
Yeah.
I
Okay.
haven't figured out where mine's different from yours yet.
It may be just my. Wait. No, it doesn't. For mine, it doesn't like the parentheses. So SQLite doesn't like the parentheses. SQLite prefers no parentheses.
Mine's on a single row. I didn't-
That's fine.
Oh, you have PC capitalized.
Oh, there you go. Thank you. There you go. Same problem that we ran into.
Why are we sensitive to it?
Oh, so in that case, it is case sensitive?
Yeah,
Because it's looking at a character.
Yeah, because a string, looking at strings, string values are case sensitive. So just be careful with that. Like, I kind of made a mistake there. Okay, so find those hard disk sizes that occur in 2 or more PCs. This should be a little bit harder than the previous ones. Anyone did that one already? Got it? Try it. What do you think we need to do for that?
I always like to just try to map it out before it goes, so we know we're looking at the PC table, right?
Yes.
So we know we have that. And the variable
And
HD hard disk.
yeah.
But we can't really do a count because
You can, but I haven't taught you that yet. So there's more than one way of doing this query. You can do it with a group by as well. But the version I'm thinking about now, don't use the group by, and just do your regular straight SQL, if you will.
no, that's because it's not, I need to go to the documentation for why except is not being acceptable right now.
I was having that same problem, but then when I moved into just one line, it worked for me.
Okay, so you put us
Can you show
Yes.
us the code from the?
Oh, yeah.
Thank you.
So if I just put all in one line,
Get rid of the backslashes.
right?
Backslashes is
I
confusing
don't
it.
have any backslashes in mine.
That's why.
But I'm not doing it, I'm
Oh.
doing it,
Oh, you're doing it in
In
your
MySQL?
in the MySQL. Yeah,
Okay.
then you don't need it.
yeah, it's not doing
It may be that because, like I said, different vendors have slightly different
Right,
quirks.
so I gotta go look for their documentation, because they're not accepting the word
Yes,
accept,
so
so they have a
they-
different word,
They may have a
probably.
different word for it. This is where things get a bit annoying with different vendors not fully compliant to standards.
So then when I go into their documentation and look for,
Is that difference?
okay,
Okay, coming
It's
back to
like a
this query, right? You see 2 or more PCs. So one thought is this, right? If I can put 2 copies of PCs side by side, right, and kind of compare them. So that's the hint I'm going to give you. Think about putting 2 copies of PCs side by side, right, and then doing something with that. Right. You may remember, if you go back to the conceptual evaluation strategy, in the from clause, right, all the tables in the from clause are joined together by a cross product, right? So what is a cross product? Right? It's like putting stuff side by side. Let me bring that up and see. So if I do a cross product, I have stuff side by side. Right? So I have R1 here, and I have S1 here, and R1 here, and I have every possible pairing of the tuples side by side. Think about that. Any ideas? Sorry? No, not really. So think of what happens if I take the PC table, right? That was the PC, right? Yeah. If I take PC and I cross PC with itself, right? Do a cross product of PCs with itself, then I would have 2 copies of PC side by side. Each row, I would have every possible pairing of PC tuples within the cross product. Now, how do we get the right rows that we want from the cross product? That's what you have to figure out.
So if HD one equals HD,
And is that enough? Yeah. You want the IDs to be different, right? So because that same hard disk size occur in 2 or more PCs. So two different model numbers, right, for the same hard disk size. So that will ensure that there's at least 2 different PCs with the same hard disk size. Okay, makes sense? Maybe? No? Okay, so one way you can do this, again, if you have trouble visualizing this, let me write the from clause first. Right, PC, let me call it A, PC, let me call it B, and in fact, let me just let you sort of visualize it first. You do something like that. And here you get every possible pairing. But really, you might only be interested in the hard disk size and the model, like what we said. Okay, so in the cross product, you have every possible pairing, including pairing it with itself, right? So I have 101 and I have model 101 here. But we're not interested in those, right? We're not interested in those. So we're only interested in those where A dot model is not equals to B dot model, and A dot HD is equals to B dot HD. So those are the things that we want. Oops. Now what did I do? Oh. Ah. Wait, but it ran earlier. Near A. Oh. Yeah, I need a space. Sorry. Dealing with strings. Yes. All right. Of course, the output only wants the hard drive sizes, so you don't really care about the rest, right? But this just shows you that you are ensuring that the model numbers are not the same, all right? So you don't really want all this stuff here. So that's all you want, all right? Note also that the result comes back as an array of tuples, right? So these are lists that are not modifiable, all right, just from a Python perspective.
Oh.
Yeah. Again, you can dump it into a NumPy array and sort of convert it into NumPy, and you'll see that that becomes useful later on. Okay. Yeah.
As you mentioned, there's like multiple ways you could implement that query. Is it in general considered better style to avoid doing things like loopy unless you absolutely have to, and going just like the raw cross product or is the performance consideration?
It all depends. There are performance considerations. Group by will mostly involve a sorting, and in this case with the join, because this is actually a join, you're just joining on hard drives size. If you have an index on join, it can be faster than sorting. So pros and cons. But some you may have an index on the group by condition as well, in which case it will also be fast. So not a big deal either way. Yeah.
So I'm getting error message, both when I include and I don't include the backslash into there?
The backslash is really a convenience thing for breaking a string over multiple lines. It's a Python thing. So if you want to make it all one line, that's fine. But the backslash, I said earlier on, I had a backslash without a space. What this happened is that it didn't include a space between B and where, and so that made it B.WHERE. So that was the error.
So mine's all in one line.
Okay.
It's saying that operational error is near the A syntax error, so the only thing
I guess which A?
break.
Is it this one or this one? I mean, from the errors, usually you should know. I mean, it kind of points to where it stops.
I mean, theoretically, it just, it's saying it's A in quotation marks, but I don't have A quotation marks. So does it mean a PCA comma?
Let me come back to that and take a look at that. It could be a really tiny syntax error. So let me come back to that. Sorry?
Can you select distinct?
You can if you want. You can do select distinct and remove duplicates. And up with only 3. Alright. Yep. Good point. Okay, so now I'm going to jump back to the slides and let's talk about, yes.
Go back to the vote for a second.
Yep.
Did the shape of the array change when we use distinct?
No, it didn't change.
So it was a studio.
Yeah, it's an array of tuples. I mean, strict Python terminology would be an array of tuples.
I thought previously it was array of arrays.
No, it was array of tuples. Yeah. So it didn't change. Where is my group by queries here? Okay, so the other kind of query that is going to be very useful for you guys, right, is the group by query, where instead of select from where, you also have a group by clause and a heading clause. And so I could explain this a little bit. It can get a little bit confusing at first, right? But what this is going to do is this: it's going to apply a grouping operation on the column names specified in the grouping list. All right. So what does grouping means? It means that everything with the same values in these columns, right, in these columns, will get grouped together. All right. And the having clause is a filtering condition on groups. Okay. So now we have two different notions. We have rows and groups. So distinguish between them. All right. The where clause does filtering on rows. The having clause does filtering on groups. Okay. You can have aggregation operators in the select clause, right? In which case, let's see. Let's see. You can have aggregation operators here, but any column names that you put in the target list must be a subset of the grouping columns. I know this sounds very abstract, but let me give you an example and kind of see why. No, let's actually do the example first. No, let me do another example. Sorry, should have ordered these slides better. Why is it so slow? Let's actually do this one. This is an easy one. Okay. So I have an employee table with ID, name, address, city, department. All right. So I can do a query select city, count star from employee, group by city. So what this group by city does is that I'm going to collect all the tuples with the same cities together. Okay, so Honolulu, 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 these three tuples form one group. All right, Kapolei, that forms another group. All right. So essentially, that's what the grouping operator does, right? But now in the select clause, right? Okay. Well, before I go to that, right? In your output, right? Your output is no longer by rows. Your output is one row per group. Your output is by groups. All right. And this is one reason why, because the output is one output row per group, right? That in the select clause, you can only have column names that are in the grouping condition, because it doesn't make sense otherwise, right? Because you're going to have multiple values per group otherwise, which will make it illegal, right? So you can only have group by columns in the select clause and any aggregation functions, right? And the usual aggregation functions are sum, count, average, max, min. Those are the common ones. If you look up the documentation for your vendor, there's going to be a ton more, like standard deviation, variance, and all of that stuff. Okay. So this is how the group grouping work. All right. And in terms of the conceptual evaluation strategy, right? Everything is same as before, right? You still do the cross product of the relations list. You still do the where clause, right? But after that, you do a partitioning of the into groups. So this is a grouping step, right? And then you apply the having clause, right? So the group qualification is then applied to eliminate groups. Um, uh, so then you're going to get, I'm not going to really go through all of that stuff, right? You group them, and then you can apply any aggregations in your select class, and you get one answer tuple per qualifying group. All right. So if we look at this query, right, select from sailors. Okay. So this now gets a lot to pass, right? Select S rating, minimum SH, minimum sailor age from sailors S, where age is greater equals to 18. So this row level filtering will be performed first, right? After that, it's going to do a group by on rating, right, on the rating column, all right? And then the having clause is a filtering condition on groups. And the filtering condition here is count star is greater than 1. What this means is that the number of items in each group has to be bigger than 1. Alright. So in the end, your answer is going to look like this. There's only 3 groups left after all the event there. Right. So again, you do your regular SQL query, right? Apply the where clause. Then the group by does the partitioning. So I'm drawing these lines. So implicitly, I'm actually sorting by rating, and then drawing lines to partition them. And then from here, I have to apply the having clause. So the having clause is count star greater than 1. So rating 1 doesn't satisfy the condition. Rating 9 doesn't satisfy the condition. Rating 10 doesn't satisfy the condition. So those are all gone. Right? And so only these 3 groups are left. Right? Then I do the aggregation, which is the minimum within each group. So the aggregation function is applied on a per group basis. All right. Minimum of this, minimum of these 2, and this is the final answer. Okay?
So having and group by, they always go together.
They always go together. Yes, you can't have having without a group by.
And you can't have group by without having.
You can have a group by without having, because you may not want to do any filtering on groups.
Right, okay.
Yeah. Yeah. Okay? Does that make sense? Yes.
Why did you take the rating down?
Why did
Why is it not in the?
why it is eliminated? Because of the having clause.
Yeah, but.
The having clause is count star strictly greater than 1.
So it has to be more than one.
Yeah. So the size of each group must be at least 1. Yeah.
I understand.
Yeah. Right? So so if we go back to the query that we just did, right, on the hard disk sizes that occur in 2 or more PCs, can you rewrite that in group by and having? What do you think? So try it. Try that now. Right, so that's a different way of writing this query. Okay, I'm just going to do it right over here. Distinct. I'm not going to do any filtering on the rows. What would you group by? What would you group by? What condition would you group by? Hard drive. Right? How are you going to filter your groups? In fact, it's going to be the same one as we did in the slides, right? Strictly greater than that. Yeah, you can do it greater equal to 2, or you can do strictly greater than 1. And we should have the same answers, but in slightly different order. And this is where the implicit sort comes through. So for Troy, you see that the answer is actually sorted. Means that a sort was done actually in this case, because we didn't. Yeah, because we didn't create any indexes for these tables. But if you create an index on the tables, you may be able to use an index, in which case, yeah.
So mine deduplicated and sorted automatically.
Yeah. I know it did. The top one is from the previous query. I didn't. Yeah, I didn't get rid of that one. Okay. Any questions on this one? Okay, let's try work through a few more queries just to get a feel for doing the group bys, because it takes a while to get used to. All right, so do a couple more. Work on G and H and I and let's see how much more you practice. Let's just do 3 and see what happens for you guys. So maybe I'll just copy it over to my Jupyter notebook. Oh, okay, because you can't refer to it. Yeah, you need to forward it. Let's see, it's not it should it's able to put a see we put the product in front of the product dot. The product dot is outside of it. Oh, then you have a problem with second context. So turn that into a double quote. Oh, but then it interpreted that as a string. So, should be on there. Everyone got G?
Mine will do that.
Unless it's not happy with
And
you?
you're reading from another table, right? Because we're doing two different tables.
Sorry?
No, sorry, I'm gonna listen while you guys do that.
So before I wasn't working with the slashes, so I've just had
Yeah.
it straight through.
And nothing?
No, it's still turning all the individual.
Oh, but that's from the first query. Because you have two
So
yeah,
then,
this is the one.
so then
Because you had
remove-
yeah, you can remove that print if you want, or you just comment it out with the hash in front. Yeah.
Thank you.
Okay, if you're done with G, go for H. I'll type out G right now. Find maker, maker from product P, PC. I'll have to join it where P dot model equals to PC dot model. Sometimes I need, I don't think so. Group by PC. Oh, um, I'm now thinking maybe I need
Because you need two tables.
no maybe I need to show you one nested query in this case. It would be a little bit cleaner. Sorry guys, I wasn't planning to teach you guys nested queries, but a G. Yeah. Yeah. I mean, essentially, you're gonna do that. The problem is, unless I group by, but then that wouldn't be accurate.
You can group by maker and then you count distinct speeds.
Yeah, I can do that, but I can't. Oh yeah, that's true. Yeah. Sorry, I was thinking about something else. Group by maker, yes. Let's do group by maker. And then having count distinct PC dot speed is at least 3. Let's do that. Yeah, I think that works. Thank you. So ACD and E. So it does work, sorry. Any questions on that one? Yeah.
I'm getting an error message. I've got no such column.
Did you define product as P? Do you set an alias? Because I have product P. Yeah. So let's practice one more. Find manufacturers who sell exactly 3 different models of PC. This one's easier actually. Find manufacturers who sell type equals to make the same mistake again. Who sell exactly 3 different models of PC. That should be it. That was easy. Oops. Okay. Try one more. Find the average speed of laptops costing over $1,000. It's not difficult. Now that this is greater and there's no group after this one. This was an easy one. Oops. Oh. Being stupid. Alright, let's see. Okay. Any questions, folks? Can I leave you to practice the rest? It does take some getting used to, so you could practice a little bit, but I think you get the feel for it.
So,
Yep.
it's saying it's an unrecognized token of will not speak.
Oh, because it's not one, it's L. Yeah. You should use capital letters for that. It'll be a bit easier. Questions? Going once? Going twice? Okay, good. Okay, this is good. Now we can move on. Okay, let me get this going. Maybe I'll go into presentation mode. Seconds. Okay. So I'm going to finish up the database part with a little bit more on what's commonly called data warehousing. All right. So in fact, this is highly related to the sort of the deployment side of analytics, and this has been around for quite a while. Right. In many organizations, you have a reporting or analytics um, department or unit that does all the reporting, and it's essentially still running off database technology, right? But it's a little bit different in the sense that for analytics or reporting, so this is sort of more the business side of things, you often want what's called a star schema. You would often use what's called a star schema, and the star schema essentially has a central fact table, and this is a table of all your transaction data, right? Think of sales at a e-commerce or supermarket kind of company, right? Or think of Walmart, for example, right? I have a central table of transaction data, right? And then I have these side tables, which we call dimensions. Ah, sorry, jumping ahead. So these are dimensions, and then these are your performance measures. All right. So in this case, you'll be sort of volume of sales, or amount of sales in terms of dollars, and this is quantity, for example. And there could be many more. All right. And then associated with each dimensions, you have a hierarchy. All right, and hierarchies are represented in relational databases, kind of really in a kind of an ugly way. It gets sort of flattened out, right, into so the most fine grained, and then day, week, month, quarter, year, right? And for product, there could be a product hierarchy with category. Sometimes those sort of multiple levels of categories. Locations, you have city, state, country, for example. And then this allows you to do some nice analytics queries over the data, as we'll see in a little bit. So this is sort of the simple one. Hierarchy. Oops, something got messed up. In fact, they could get a bit more complicated with what's called a snowflake schema, right? In which case, something got messed up. I'm gonna fix all the alignment of the drawing. Again, you have your central fact table, but now some of your hierarchy tables has got further breakdowns into more tables, right? So it becomes more like a snowflake. And sometimes you have multiple fact tables, you have a shipping transactions versus your sales transactions, and they might be sharing some hierarchies. This date again, time, the branch of the store branch, location, this is the product hierarchy, this is the shipper information. And so you have multiple fact tables sharing dimension tables. Okay. And there's a class of queries that, at least in the database community, we call OLAP queries, and that is short for online analytical processing, right? And we've seen some of these, right? We have aggregation queries, like the group bys that we saw, right? When you aggregate a measure over one or more dimensions, so there's a notion of your fact table, and then your dimension hierarchies, if you will, forming a queue or hypercube, right? And you might be interested in, say, finding the total sales for each location, finding the total sales for each period in time. Then you have top K queries, where you're finding the top 5 products that rank by total sales. Again, think about this. This is really an order by query, right? You have an order by to rank things, and then you can limit your result to the top 5 products using, I believe in SQLite is a limit command. You limit 10, limit 5 at the end. With these slides. Then you have slicing and dicing, where you're actually doing equality or range selections on one or more dimensions, right? Like, sorry, let's see this. Find total sales for a single product line at a single location. Roll up is when you aggregate at higher levels of the hierarchy, right? So you're given total sales by city, you can roll up to total sales by state, for example. So these are called roll-up operations. Drill down is the opposite, where you try to get more details for a particular dimension, right? So there's a roll up. So given total sales by state, I want to drill down to get total sales by city, for example. I can also drill down on a different dimension to get total sales by product for each state, for example. All right. Then there is the notion of pivoting, and some of you who have used Excel spreadsheets or Google spreadsheets, you may be familiar with pivot tables, right? This is the same notion, right? Where you're aggregating on selected dimensions, right? So if I do a pivoting on location and time, right, you're basically creating a cross tabulation of location here and time here. And you're computing all the different group bys and aggregations in this table, right? We'll sort of show that to you. So you have, in this case, just 2 locations and 3 different years. And this essentially is just a bunch of group by queries, right? This center portion is just this group by year and state, right? And for each of these form a group, and we'll give you one of these numbers. You're summing that, right? And then this red part is just group by year, and this red part is, as you guessed it, group by state. And this is the grand total that is just, the sum of everything. All right. And sometimes we like to think of this as cubing, and some systems will support the cube operator, right? Where, again, you can generalize this to multiple dimensions. So that was just two dimensions, but you can generalize it to any dimensions, and the number of different combinations that you get will sort of form a lattice, just for those who are interested in such things. So it's an abstraction. Like in this case, I have just this group by year state and group by year and group by state. But if I have 3 dimensions, I would end up with these different possible combinations of the dimensions. And those are the different group by queries that you will get in order to create your tabulation, your pivot table, if you will. Okay. So some systems support the cube by operator, right? Where you cube these 3 dimensions by sum on sales, right? In which case it will go ahead and compute this query where the grouping list is each of these cells. Alright. So anyway, but this is just really kind of FYI for you guys. And then typically what happens is that I'm going to skip over data integration for now. I'm going to do this. Maybe I'll just talk about it briefly. This is actually good. So typically what happens with these data analytics deployment is that you start with your data sources, right? And you could have multiple data sources. You will pull all the data into a data warehouse, right? And this process is typically called ETL, extract, transform, load, right? And then you will develop your analytics over this data warehouse. And there's a bunch of different tools you can use for this. There's expensive ones and not so expensive ones. And I believe some folks here have used Tableau. Tableau is a nice visualization tool that lets you create these dashboards over your data warehouse. And stuff like that. But again, this step is the tricky step because this step requires you to do data integration and data cleaning over these data sets. Right? And so that's a really crazy thing because sometimes you can have multiple data sources. Some of them are relational, some of them are not, and you are basically trying to pull them all into a central data warehouse, right? And there are different ways of doing it, which I'm not going to go through too much at this point. But essentially, you're trying to create a global schema, and this global schema is typically going to look something like the fact tables and the star schemas that we saw earlier. Sorry, all my alignment somehow. So mapping the data sources into your global schema, that's the tricky part, and that's called the schema mapping problem. It gets really ugly very fast for real data sets, and people would often underestimate that. I'm going to skip the examples because they're a little bit too esoteric. Okay, but let's talk about some of the key steps, right? So you have to specify your global data model and your local data model. Again, think schemas, right? You have to figure out the data formats of the attributes and their meanings, any abbreviations, terminology, and ontologies that's being used. You have to map the local, which is the data sources, right, to the global schemas, right? And I'll go down to that, right? So, for example, attributes with the same name may mean different things, right? In different data sources, like the example that income in one data source could refer to self-declared income. Income from a different data source could mean income that has been verified from tax records, right? So be careful when you're trying to pull data together because they might mean different things. Alright. Let's see. Values of attributes with the same name may use different terminologies. This is, for example, if you're looking at sort of health claims or medical data, the same drug can be encoded in different ways, right? Again, when you're pulling data from multiple sources and trying to put them together, you have to worry about issues like that. And then there's basically a whole bunch of data quality problems that you've got to figure out, right? You have to resolve overlaps or duplicates, and this is the idea that how do I determine if the customer from an insurance database and a patient from a hospital information system, do they refer to the same person? How do I determine that, right? In a perfect world, there's a unique ID, maybe it's a social security number that will help to resolve that, but it's getting increasingly difficult because now it's that you don't share social security numbers anymore, and that makes data integration even harder. Alright, so IDs are good actually. You can figure out how to handle missing data, handle inconsistent data. Inconsistent data is basically you have say telephone numbers, right? Telephone number for the same person, but you got two different numbers. One of them could be outdated, right? You figure out how to handle stuff like that. You can use what's called an ETL tool. There are commercial tools available for doing ETL, and they are typically rely on a cluster of machines because they're typically meant for people to try and convert a huge chunk of data in a short time. So it can be expensive, but otherwise, for most of you guys, you're probably just cleaning the data using your Python scripts. Alright, so you won't really worry about that too much. Okay, now I'm not going to do that one, and okay, that's it. Oh wait, I went over. Oh, almost. Not too bad. Okay, so at least for your homework, at least for your first homework, you're using data that's relatively clean, right? You're not going to have any missing data or inconsistent data and stuff like that. So, but I might try and give you one homework where we have more realistic data, where there are some data issues, which then you might have to work through. So maybe homework 2 or homework 3.
That would be real connection.
Sorry?
That would be real good.
Yeah.
Seriously, to get experience about
Yeah, where you have more realistic data, where you might have missing values, then you really have to look through the data carefully. I'm sure you're dealing with that.
It's fun, yeah.
It's fun, right?
Right. When you get NAs and you're like, why does it say NA? I don't really know why it says that. Or, oh, where'd the names go? It's supposed to be attached to that ID and now it's a number. All right, that's great.
Yeah. Okay, guys. Oh, okay. Thursday, I'm not going to be here. We're not going to have a face-to-face class. I'm going to be posting materials on the website for you to go through on your own. Okay? So no face-to-face class on Thursday, but I'll be posting stuff. You guys have to work on stuff on your own, okay?
Sasha and I are going to meet here anyway at 11 to do some other like assignment ones stuff. So if anybody wants to meet together, we'll be in here.
Yeah,
11?
We're meeting at 11 to do some project stuff, but we'll be here through like at
Happy
12.
class time.
Yeah.
yeah, so come by. And yeah, I definitely like seeing what's happening on Slack. People are posting answers and helping each other out. I really like seeing that.
I forgot we have a Slack. I gotta add to that too.
Oh, did you get an invite?
I'm on it. I just also have one for the Epic conference.
Oh, okay.
And then
Yeah, too many, right? Yeah, I know.
too many things to do right now.
Yeah.